Welcome to our two-part lesson on how to solve quadratic equations by completing the square. In this two-part lesson, the first part is going to be just breaking down, reviewing perfect square trinomials, and understanding the square root property. The part two of this lesson will actually go into the steps of how to complete this perfect square and then solve your quadratic equation. All right, so let's review how we get a perfect square trinomial. So a perfect square trinomial comes from taking a binomial and squaring it. If I have x plus 4 squared, that is the same as taking x plus 4 times itself, and that would result in x squared. My outers give me 4x, my inners give me 4x, so that gives me a center term or a linear term of 8x, and my lasts give me 16. If I repeat that process for the next two examples, x plus 3 and x plus 3, that gives me x squared. My outers and inners give me 6x, and my lasts give me 9. As well as x minus 2. If I repeat that process, I end up with firsts, my outers and inners collectively give me negative 4x, and my lasts give me 4. Now, if you take a step back and look at my perfect square trinomials, so all of these are perfect square trinomials because we took a perfect square to get that trinomial. But let's look at their properties. So notice that the last number is always a perfect square. And to get that perfect square, it would be the same as if I took this number and divided by 2 and squared it, which is our linear term. So if I take 8 divided by 2 and I square that, that's 4 divided by 2, squared gives me 16. If I take 6 divided by 2 and I square that, 6 divided by 2 is 3, 3 squared is 9. If I take negative 4 divided by 2, that's negative 2, and I square that, that gives me 4. So if I make a general rule from this, to get a perfect square trinomial using my standard form of a quadratic, I simply am going to take my center term or my linear term, divide it by 2 and square it, and that's what's going to give me C. That results in a perfect square trinomial. Okay, so how are we going to use this? So we're going to use it to solve quadratics that might not always give us a perfect square value or integer values as our factored points. All right, so if you remember when I said when we solve a quadratic equation, we're always going to have it set equal to 0 except for when we're using the completing the square process or the square root property. So this is going to be the exception to the rule where I always have to have it set equal to 0. Now what I'm going to do first is I'm going to look at this and kind of dissect this. If I take that 22 divided by 2, that gives me 11, and 11 square is 121. So that means that this quadratic is already in perfect square trinomial form. So if I need to solve this problem, what I'm going to do is I'm going to factor it into its two perfect squares. So if I factor this, I'll get t and t, and I'll get 11 and 11. Now if I do my quick check, my firsts give me t squared, my outsides and my insides together will give me 22t, and my last will give me 121. Now I'm going to keep this set equal to 28 because for this process, I don't need to have it set equal to 0. All right, now I'm going to write this as its perfect square. So this is really t plus 11 squared, and that is set equal to 28. Now what I can do, since I have this perfect square, I can utilize the square root property. And the square root property says if I have a square root, then I can square root both sides to get rid of it. Now, my left side is a perfect square, but my right side needs simplified. It is not, and that's okay to not have a perfect square. All right, but when I square root the left side, I'm going to undo the square and be left with t plus 11. Now, when using that square root property, remember that that could have been a positive t plus 11 or a negative t plus 11. So I'm going to transfer that over to the 28. So it's going to be positive or negative square root of 28. Now, I know that there's a perfect square in 28. I'm going to come over here and factor that perfect square out. So when I square root, I can make this positive or negative 2 square roots of 7 is equal to t plus 11. Now once all of those squares are gone, I'm okay to isolate this t and finish this problem. I'm going to take that 11 to the other side. That's going to give me 11 plus 2 square roots of 7, but it's also going to give me negative 11 minus 2 square roots of 7. Now you can see that that probably would have been a very difficult problem to find by our other methods of solving that we have so far, which are graphing and by factoring. So this completing the square method will work with any quadratic function that we have. All right, so that's what's good about it. All right, so let's try a few of these. Now, these ones are already set in perfect square form, and I'm going to just verify that. So if I take 14 divided by 2 and verify, that gives me 7, and 7 squared is a 49. So this is already in a perfect square form. So when I factor that, that's going to factor into x plus 7, and x plus 7 is equal to 64. Or x plus 7 squared equals 64, so that it is written in perfect square form. Once I have it in perfect square form, I can square root both sides by the square root property. And that's going to give me x plus 7 is equal to positive or negative, and the square root of 64 is 8. And then I have to finish by isolation. So x is going to give me negative 7 plus 8, which is equal to positive 1, or x is going to be negative 7 minus 8, which is negative 15. So my x gives me two choices, either negative 15 or 1. So that would have been one that if I graphed it, I would have been able to find those point values on my x-axis very easily. All right, so why don't you pause the video and you try this one and then play it again and see how you did. So I'm going to verify that perfect square. So I'll take negative 16 divided by 2, which is negative 4. Which is negative 8. And negative 8 squared is 64. All right, so that means that this is going to factor, since this is a minus, it's going to factor into x minus 8, and x minus 8 is equal to 25, or it factors into x minus 8 squared equals 25. Once I have it in perfect square form, I can go ahead and square root both sides. That's going to give me x minus 8 equals positive or negative 5. And I'm going to go ahead and isolate from here. So x equals positive 8 plus 5, or 13, and x equals positive 8 minus 5, which is 3. So I'm going to have two integer values for my solutions to the equation. So x is equal to 3 or positive 13. Okay, so let's look at one that might not turn out so perfect like the last two. So I verify, first of all, do I have a perfect square? So I'll take that negative 10 divided by 2 and square it. That gives me negative 5 squared is 25. So it is a perfect square trinomial. So from there, I'll factor into x minus 5, and x minus 5 is equal to 12. Or it's x minus 5 squared equals 12. Once I have it in perfect square form, I can square root both sides. So that's going to give me x minus 5 equals positive or negative. Now I have a little problem because 12 is not a perfect square. So I'm going to come over here and I'm going to simplify the square root of 12 like we've done in the past. So I'm going to factor it out, and I see that the number 4 is a perfect square. And the square root of 4 is 2, so that's going to simplify to 2 square roots of 3. So I'll have x minus 5 equals positive or negative 2 square roots of 3. Then I'm going to take that 5 over, and I'll get 5 plus or minus 2 square roots of 3. Now, I can't really do the math on that without taking it to a decimal or a rounded value. So I'm going to leave two choices, 5 plus or minus 2 square roots of 3. Now you can see that if we were to graph that, that would have been really hard for us to find on the x-axis. And that probably wouldn't have factored very nicely using the factoring method. But completing the square will work with all methods. All right, let's try this one last problem together, and then we're going to go into our part 2 series tomorrow and talk about when it isn't a perfect square, how to make it be a perfect square. So I verify again, negative 4 divided by 2 is negative 2, and negative 2 squared is 4. So that means that the factors of this have to be x minus 2 and x minus 2. That's going to give me x minus 2 squared is equal to 8. Now I can utilize the square root property. That will give me x minus 2 equals positive or negative. Now I'll have to go ahead and factor 8. And that's going to factor into 4 and 2. So square root of 8 will break down into 2 square roots of 2. And then I can take that 2 to the other side. So my solutions will be positive 2 plus or minus 2 square roots of 2. Now I can't add those together because those are not like terms. So I'll leave it broken into x equals 2 plus or minus 2 square roots of 2. All right, look for part 2 in our series of completing the square lessons. I'll see you tomorrow.